My name is Daniel Kwon and this is KTH Math Tutoring Club. Today we're going to go over AP Calculus BC Free Response Question 2016 number 6. Number 6, let's start with Part A. Part A asks us, write the first 4 non-zero terms and general terms for the Taylor series for f about x equal to 1. And before anything, because it asks us the Taylor series, we have to know what the Taylor series is. Here, I have pasted this equation for the Taylor series. So by knowing this, the f1 and f'1 is given to us. Let's first write f1. Because it's x equal to 1, this a will be 1. Here, I've copied down the exact formula, but just plugging in 1 because the question asks us f about x1. So, you'll be asking, this is first four non-zero terms. However, I wrote until 3. This is because literally you can translate to non-zero terms, right? So f1, if we look at it, f1 equals to 1, so it is not 0. Thus, we can count starting from here and count 4 terms. 1, 2, 3, and 4. Just like that. And let's plug it in. So f1 equals to 1, f'1 equals to -1/2. So I've written 2 given formulas, and it says nth derivative of f at x is 1 is given by this formula for n is greater or equal to 2. So starting from 2, we should use the given equation about f. So you'll be confused. What's f'2? We can just plug it in. So because we want the second one, we will plug 2 for n. I've written down the formula, and now let's plug it in. First, we need the second derivative, right? So right now, for this equation, n equals to 2. So when n equals to 2, it'll be 2, right? So -1 squared will be 1, so it cancels out as in 1. And 2 minus 1 is 1 factorial over 2 squared. This will just equal to 1 over 2 squared. Thus, this will become 1 over, you see 2 factorial. 2 factorial just equals to 2, right? Times 2. Let me write this more clearly. And x minus 1 squared. Now, lastly, the third prime. So because right now we're solving for the third prime, n will now be 3, right? So we plugged in 3 for each n, so n3, 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 and let's calculate. So this will be negative because of -1 times -1 times -1, and 3 minus 2 will be 2, so 2 factorial will be, so let me do it step by step, over 2/3, right? So this will equal to -2 over 2/3. And now, you have to notice that this f third prime is -2 over 2 to the power of 3, and then over 3 factorial. However, when we look at 3 factorial just equals to 3 times 2 times 1. You see, 2 cancels out, 1 stays still, so this will eventually become 1, like that. So this will become negative. So this is our first part of answer. However, the part A still asks, write first 4 non-zero terms and general terms for Taylor series. So we have to find the general term. What is general term? General term literally is solving for an equation where we just plug in the number, such as like this, where we just plug in the numbers to make this kind of equation. So, because it's general term, we could write, and then as you can see, our equation starts from +1 to negative to positive to negative to positive. That means we need this -1 factorial. So if we plug in 1, it will be negative. If we plug in 2, it will be positive. If we plug in 3, it will be negative. It will turn alternatively. And then, as you can see, foremost, we need x minus 1 nth term, right? So x minus 1 to the n, because it's from 1 to 2 to 3, right? Next part we have to do is this. When you look at the bottom, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and times 1 times 2 times 3, right? So, what does it mean? When it's 2 to the power of 1 times 1, 2 to the power of 2 times 2, 2 to the power of 3 times 3. That means this will be 2 to the power of n times n. And that is it. This is our general term. Positive dot dot dot. So this will be our answer for part A.